All right, we're doing chapter 2, the getting started. So these are the skills that will be needed within this chapter 2. Want you to try to do some of these without a calculator. So I'll let you know as we go through. So question 1, calculate 1/2 times 20. Let's do these without a calculator. So think about multiplying 1/2 times 20. Think about what it means, half of 20. That means the same as dividing by 2. Okay, if you think about fractions, you can do it that way. 1 times 20 is 20. 2 times 1 is 2. 20 divided by 2 is 10. So this is a review of fractions from really from elementary school. B, 1/4 times 24. So you're taking 1/4 of 24. You're dividing 24 by 4, which is 6. Then C here, 3/8 times 16. So think about how many 8s in 16? There's 2. 3 times 2 is 6. So you can actually divide that out if you remember back from working with fractions. So then you're left with 1 in the denominator. 3 times 2 is 6 over 1 is 6. And D, same thing. 16 goes into 32 twice. 7 times 2 is 14. Why are we using, these are all denominators with multiples of 2? Because in this unit we'll be learning about measurement conversions, including the imperial unit of measure, and that measurement involves a lot of fractions, 1/2, 1/4, 1/8, 1/16, or multiples of those. Question 2 is more about decimals, and that's more in the metric unit. Again, we'll be doing that in this chapter. So calculating these, again, without a calculator. They're decimals. If you multiply anything by 1, it stays the same. Okay, next one, multiplying by 10. Remember, multiplying by 10 moves the decimal place, which is after the 8, 1 to the right, and you fill in with a 0. So that's going to be 680. Here we're multiplying by 100. It moves the decimal 2 to the right. So that's going to end up being 12.5. And here we're moving the decimal 3. The number of zeros determine how many decimal places. So 1, 2, 3. So we have to fill in with a 0. So that's going to be 72,560. So it says describe a pattern for multiplying any number by a power of 10. So that is, the pattern is the power of 10. So the number of zeros in the power of 10 determines how many place values to move the decimal to the right. Okay, so for example, 10 squared is 100. So there are, I'll do this in red here, there are 2 zeros, and that is the exponent on 10. So that tells you how many decimal places to move it to the right. Okay, so evaluating these powers of 10. So same thing here. I just did that one. 10 squared is 100. You don't need a calculator. 10 cubed is 1 with 3 zeros. 1 over 10 squared would be 1 over 100. Okay? If you wanted to find the decimal form of that, then you would divide that. Really, you're moving the decimal then 2 to the left here. So I'm going to put that in brackets. It didn't ask you to do that. Usually evaluate, you leave in simplified form as a fraction in lowest terms. So this will be 1 over 1,000. Okay, but again, if you did do that conversion to a decimal, there are 3 zeros, so there are 3 decimal places. Okay, question 5, again, we're going to evaluate without a calculator. Anytime you're dividing by 1, it doesn't change the number. If you're dividing by 10, then this is a power of 10, 1 0, so you move the decimal 1 to the left. So that'll be 9.6. Here you're dividing by 100, 2 zeros, so you're moving the decimal 2 to the left. Oops, sorry, 2 there, 3.55. And then dividing by 1,000, 3 to the left. And you fill in with a 0. And it's always best to put a 0 in front, then the decimal, 0.2375. Okay, so describe a pattern for dividing. So we'll use some similar terminology. The number of zeros in the power of 10. So the number of zeros in the power of 10 determines how many place values to move the decimal to the left. When you're dividing, okay, then you're going left. You're multiplying, you're going right with the decimal. Okay, and then put these measurements in order from least to greatest. So hopefully you remember some of your metric system. We'll go over it, but take a look at these. So kilometers, centimeters, meters, millimeters. So millimeter is the smallest actual unit, and kilometers is the biggest, then meters and centimeters, but you want to think about converting them to the same unit. Meters is sort of the most common, especially when you're dealing with kilometers. So remember, there's 1,000 meters in a kilometer, so that would be 2,000 meters, okay? There's 100 centimeters in a meter, so we would divide. So here we're multiplying by 1,000. Here we divide by 100, so that would be 2.65 meters, okay? That is in meters. And millimeters, there's 1,000 millimeters in a meter, so we would divide by 1,000. So that would be moving the decimal 3 to the left with 1.235 meters. Okay, so we want to go from least to greatest. So the smallest would be this. So 1,235 millimeters, then 265 centimeters, then 4.8 meters, and then 2 kilometers. Okay, so that's the first page of the getting started. Turn to the next. This says calculate and round each product to the nearest tenth. Okay, so these involve some decimals that I'm not going to ask you to do those by hand, because you will be allowed a calculator for a lot of the workbook sections of this course. So that's already done for you. And it says round each product. Remember, product means the answer when you multiply. Okay, and round to the nearest tenth. So rounding, we want to circle the 10th value and then look directly to the right. If that number to the right is 4 or less, then you keep it as the original 10th value and you get rid of anything afterwards if it's in the decimal. So that's what's going to happen. This will be 59.9. Here are the next one, so you can get out your calculator. Okay, and when we multiply these, 25.7 times 17.5, we get 449.75, and then rounding that. So circle on the 7, 5 or greater makes this go up to an 8, so 449.8. And then you don't fill in with any zeros if it's in a decimal. Next one, 0.5 times 0.95 is 0.475. Rounded, again, circle the 4. 7 afterwards makes that go up to a 5. And then 12.84 times 15.36. And that's 197.2224. Round the 2. The 2 afterwards is less than 4 or less, so that stays as a 2. Okay. All right. Then it says complete each pair of equivalent fractions. So equivalent means they reduce to the same fraction. So we want to look at multiplying or dividing the original fraction, both in the numerator and the denominator, by the same value. So here, to get 16, I would multiply by 2. So I have to do the same in the numerator. So that would be a 6. Here, the numerators are given. Here I would divide by 8. Okay, so then here I have to divide by 8, which would give me 3. In C, here I would divide by 9. So here I need to divide by 9, which would give me 3. Here you'll notice that you can't just multiply or divide by a natural number to get 3. So what do you do here? Well, what you could do is divide 3 by 2, and you will get 1.5, and then you can multiply through. So here, so what I did was I went, okay, 3 divided by 2 equals 1.5. So that's what I have to multiply 2 by to get 3. And so when I get that, it's 9. Or what you could also do is cross multiply. So if we set this up as an equation and use x, like you've done back in junior high, then you're really multiplying through. That would give you 2x equals 18, and solve that equation. Okay? And then as well, you could also reduce 2/6 to 1/3 and then multiply through. So there's a few different ways of doing that one. Question 10, circle the ratios that are equivalent to 4/5. So remember, ratios are fractions as well, so we can call them both things. Equivalent to 4/5, you'll notice this 4/5 is in lowest terms. So can't go any lower. So for example here, 2/3, I would have to divide 4 by 2 and 5 by 2. Well, that doesn't give me 3. So that's not going to work. Right away I can cross that off. Next one here. So you could reduce all of these because this is in lowest terms. So maybe that's what I'm going to do here. So 16, if I divide that by 4, top and bottom, I get 4/5. And that's what I want. So that works. Here, not going to be the same, right? This is already reduced, as is 4/5, and they are not the same. Here, if I reduce this, divide by 3, I get 4/5. So that works. Here, 8 goes into everything, divide by 8, I get 4/5, so that works. Here, reduce this, so let's go by 16, that would be 4. Oops, divide by 16 to get 4. And then divide by 16 to get 5. So this, I'm just going to fix that a little bit. So this is going to be 4/5. Okay, so the circled ones are all equivalent to 4/5. And then question 11, Tanya knows that the ratio of boys to girls in their class is 3:5. Since 20 of the students are girls, so this is boys here, and this is girls. 20 of them are girls. She says that there must be 30 in her class. Is she right? So this is boys plus girls. So just remember, it's not just the ratio. So we've got 3:5. 20 are girls. So we don't know what the boys are, but we know that there are 20 girls. So this is basically equivalent ratios in the colon form as opposed to fraction form. So here, if I look, I need to multiply by 4 to get 20. So here I'd have to multiply by 4 and I would get 12. So the total number of students then would be 12 plus 20, which is 32. Okay, so she is incorrect. Okay, close, but not quite. And then number 12, Bandits won 9 of their first 20 soccer games. If this continues, about how many games would you expect them to win in 30 games? So here I'd probably show this in fraction form. You kind of think, okay, 9 wins out of 20 as opposed to ratio form. So this is the wins. Actually, maybe I'll do that in red. So this is wins, and this is total. If this continues, about how many games would you expect them to win in 30 games? So then, out of 30 is your total, and we want to know how many. Okay, so again, you can look for a number to multiply through here. So this, I know that 30 is 1.5 times 20. If you're not sure, go 30 divided by 20, and you get 1.5 or 3 over 2. So then this, 9 times 1.5, that would be 13.5. 9 plus a half, 4.5, 13.5. You obviously can't play half of a game, but it says about how many. Okay, so I would say I would expect them to win 13 or 14 games out of 30. Now, if you wanted to solve this using cross multiplying, so you would have, or using, sorry, I'm going to do this, using more algebraic skills, then your equation would look like this. We'd use x for the number of wins, and then you would multiply through. Okay, this can only be done. A lot of math teachers, including myself, don't really like talking about cross multiplying. Really what you want to do here is multiply through by 30 to get x by itself. So actually I'm going to erase this because this one's pretty straightforward that way. So you don't really need to think about cross multiplying. You want to multiply through by 30, both sides. And this dot, when it's shown here, that means multiplying. It's not a decimal because it's an operation. So you can see those divide out, and then you will get x. Here you'll have the zeros divide out. You'll get 27 over 2, which is the same as 13.5. Okay, so that's the end of getting started.